All right, 4 with an exclamation point. What does that mean? 4. You're excited.
It's a really important 4.
4, 3, 2, 1. You guys know 24, right? It means 4 multiplied all the way down to 1. It's called factorial. Factorial means factors or things multiplied. That's why they call it that. It means multiply all the way down to 1. 4 factorial. 4, 3, 2, 1. You have a button in your calculator that'll do it, or you can just do it by hand. On the TIs anyway, it's under the math button, and then go right a couple times to the PRB menu, probability menu, and then go down. You'll see exclamation point down there somewhere.
PRB, yeah.
TI, math, probability, down. On that, you'll find the button, but you don't need to. You can just go 4, 3, 2, 1, multiply them, and get it.
Let's get at the same time.
It's showing up. Yeah, you go right 3 times, don't you? To the probability window, and see it down there? Exclamation sign number 4. And there it is. So you got to put the number in first, and then go find the exclamation point. That one. Okay, so number 3. All right, so we're starting sequences. What's a sequence? Well, that's like a formula, n over n plus 7. It's basically a little formula, and they're saying to me, hey, I want you to take that formula, I want you to plug in 1, and tell me what you get. That's what they're saying by A1. They're saying, take that formula and plug in a 1. Tell me what you get. So that's pretty easy. 1 over 1 plus 7. 1/8. 1/8 on that one. So A1 is 1/8. Then they're going to say, okay, that was great. Now plug in 2 and tell me what you get. So now I'll plug in 2. Whoops. 2 over 2 plus 7. 2 nights. Now plug in 3. That's 3/12. Wait, is that 3/12? Am I doing that right? It's 7. Why am I doing 9? Yeah, thank you. 3/10. So they're going to ask you for all 5 answers. First answer, second answer, third answer. 2 more. So then they want you to plug in 4, not 3. I'm having trouble with this. We're plugging into this formula. So 4 over 4 plus 7, 4/11ths. And then finally plug in 5. 5 over 5 plus 7, 5/12ths. There we go, good? All is well? All right. Okay, so they're giving me here. This time the formula is 2 over e to the n. Same deal. They want me to plug in 1, 2, 3, 4, 5. So if you plug in 1, what are you going to get? 2 over e to the 1. They want you just to leave it that way. And you plug in 2. What are you going to get? 2 over e to the 2. They want you just to leave it that way. On you go. 2 over 3. It'll be 3. Oh no, the top's always 2, huh?
Yeah.
2 over e to the what? You know, whatever. Let's move on. Okay, so now they want us to play the game backwards. They're giving us the terms. They're saying, hey, the first one came out to be 1. The second one came out to be 1/3. The third one came out to be 1/9. The fourth one came out to be 1/27. What was the n formula we were plugging into?
1/3.
So in other words, they plugged in n equals 1 to some formula, and they got a 1. They plugged in n equals 2 to some formula, and they got 1/3. They plugged in n equals 3 to some formula, and they got 1/9. They plugged in n equals 4 to some formula, and they got 1/27. What is that formula? Name that tune. What is that formula? Any ideas? You know what you do on these? You just guess around, you keep tinkering until you get it finally.
Yeah.
So really, yeah, I don't have a magic crystal ball here. You just guess around. So, any ideas? Some sort of a 3 thing's a good idea. Yeah. Something with a 3, because you see all them 3, 9, 27, some kind of 3 things happening. Any ideas? What is it?
It's divided by 3.
It's dividing by 3.
1/3.
So how do I write an n? Like I need something like 2 to the n plus 1, or 3 to the n, or 1, you know, something like that. I need some kind of n formula.
You know it's 1 over something.
1 over something. 1 over 3. Where's the n go?
The
So the n has to be somewhere here.
We're just playing hangman now.
What do I do?
Underneath the 3.
Underneath the 3, like this?
More like hanging.
I'm not sure that's a math operation. What's he doing? He's just hanging.
It's a formula.
1/3 to the power of n.
1/3 to the power of n. Like that?
Yeah.
Let's give it a try. It's our first valid suggestion. Let's try it out. So how do you try it? That's a good way to start. Just take a guess. And because what you'll see, one of the things I learned in taking a million math classes and after solving a million these kind of things is I learned by staring at it, I learned nothing. But when I start writing things down and plugging in numbers, all of a sudden insights start flowing. So yeah, just write something down. Even if it's a dumb guess, it doesn't matter. I'm not calling your desk dumb. Your guess dumb. This is close actually, but you'll learn and then you'll hone in on it real quick. Just guess. Write something down, and you'll start learning. So is that right? How do we check? Plug in 1 to that formula and see if you get a 1. That's what you're supposed to do, right? So if I take that formula and plug in a 1, what's 1/3 to the 1? 1/3. It's not 1.
Isn't it?
What if I plug a 2? I get 1/9. It's supposed to be 1/3. What if I plug in a 3? Well, let's keep learning. There's a little more learning, and then we'll make a more educated guess next time. Plug in a 3, I get 1. See how it's best back 1? It's really close. It's just back 1, isn't it? 1/27 is supposed to be there. 1/9 is supposed to be there. 1/3 is supposed to be back there. It's close. It's close. It's just off 1 mark, huh?
Wait, what is it? 1/3 to the power of n. N is minus 1/3.
No, minus.
Well, you want to replace the n with minus 1/3?
No, n is minus 1.
What's that?
1/3 to the n minus 1.
N is minus 1? Just like that?
No, n minus 1.
And
N minus 1. Like that? Is that right? All right, let's go try it. It's a good next guess. See how she's thinking about that? Because she's thinking, I just need to back things up by 1.
What, in the first one?
Let's see. Let's plug in a 1. Let's try it out. So 1/3 to the 1 minus 1.
It's just 1/3.
1/3 to the 0. What's anything to the 0 power?
1.
Ooh, so far so good. Right? 1, right? Let's try the next one. All right, so 1/3 to the, plug in a 2 now. 2 minus 1. 1/3 to the 1.
Okay, looks like it.
Ooh, yeah, it's looking good, isn't it?
All right, we can stop.
And then 1/3 to the, now plug in 3. 3 minus 1. 1/3 to the second, 1/9. It's working beautifully. That's the formula, isn't it? 1/3 to the n minus 1 is the right formula. Now, there's another way to say that same formula. 1/3 to the n minus 1. That's the same thing, isn't it?
Oh yeah, it's just green.
Same thing. Either way. Both are good. Does that make sense? So you just tinker around till you get it. Good job thinking about the n minus 1 thing on the 1/3. All right. Okay. So 9. Hey, let me take off the minus sign. We'll do the minus thing in a minute. Let's just start with this first off. Let's make them all positive. We'll do the negative thing in a minute. Just 9, 18, 27, 36. Try finding an n formula that'll make that happen. Remember how it works. You want n equals 1 to become 9. You want n equals 2 plugged in to make 18. You want n equals 3 plugged in to be 27. You want n equals 4 plugged in to be 36, right?
It's -18 and negative 36.
I know. Yeah, I took off the negatives for now. Yeah, because negatives is too much to think about all at once. Let's just first get the positive thing going, and then we'll worry about the negative. I'll show you how to do the negative thing in a minute. But just can we just get the positives first off? What formula would crank out just the positives first off?
9 to n.
What's that?
9 times n.
9 times n? Let's try it out. 9 times n. Is that the right formula?
Yeah.
So plug in a 1. 9 times 1 be 9. Plug in a 2. 9 times 2 be 18. Plug in a 3. 9 times 3 be 27. Beautiful. It's working perfectly. 9 times 4, 30. So that's it. It's 9 times n, huh? So that's the formula. Now, how about the fact that really it's a positive 9, negative 18, positive 27, negative 30. They alternate signs. Positive, negative, positive, negative. What in the world makes that happen in a math formula?
The negative sign.
Why does it switch, though? If you just throw a negative, it's always negative, right? What's going to make it switch back and
When it
forth?
becomes square. When it's squared, right?
When it gets exponential by an odd number.
So what do I need to put? So So what do I need to put in this
Well,
math
it's
formula here?
Negative times a negative makes a positive.
So what do I need to put in this math formula here?
So it's negative 3 to negative 3 squared n, or negative 3 n
Negative 3 squared n, like that?
Yeah.
Isn't that just negative 9n?
Wouldn't it be n?
Yeah, because.
Won't that just always be negative?
The negative.
No, that'd be.
Wouldn't it be n
Please?
to the second?
Into
So
the...
then odd numbers will stay negative will be
So you want me just to take n to the second like that?
negative n.
Oh, okay, Luis, is this what you mean, n to the second?
More of a yes, I do mean that, but then a negative attached to either the 9 or the n, so that when it goes to odd numbers, it stays negative. And
I know what you mean. You're thinking right as far as somehow we got to have the powers make the negative positive thing go back and forth. But the n's got to be in the power. You see the trick? N can't be the base. I mean, n's the base for this part of it. Here's what it is. It's minus 1 to the n or minus 1 to the n plus 1. That's the way you make signs switch back and forth. It's one of these two versions. Now, how do you know which is which? Why do I say there's two versions? It depends if you want to start positive or start negative. This one, if you plug in 1 here, it's negative 1 to the first power, so it starts negative. This one, plug in 1, it's negative 1 to the 1 plus 1, negative 1 to the 2, it starts positive. So what do we want to do? Start positive. So we need this one. So the answer is 9n, and then you throw on this minus 1 to the n plus 1 thing. There it is. So that little piece, that little minus 1 to the n plus 1, that's the switcher. Right? That makes sense? That's the positive, negative, positive, negative, positive, negative switcher is what that does. Good on that? All right. So what does that mean? So we have A1. They're saying A1 is negative 4. So I'll just fill in this box right here, right now. A1 is negative 4. That's the first term. They want us to find the first 5 terms. They want me to find A2, A3, A4, and A5. A1, the first term, is negative 4. They're giving me that. They're handing me that. No work needed for that. But they want the other 4. How do I find them? Well, it all comes from this formula. AN is n plus A sub n minus 1. It's all about that formula. Now, what is that formula? You want to speak that language. What that's saying see how the n minus 1 is lowered down and this n is lowered down, but that n is on the level, right? Stuff that's lowered down, subscripts, right? Subscripts, that tells you the term number it is. So this is a subscript also, right? What this says is, put in more common English, the nth term is equal to n plus the n minus first term. That's what that's saying. That's saying any nth term is n plus the n minus first term. Now let me say it even more plain than that. What does that mean, n minus first term? That's the previous term. That's one back. So in other words, it's saying, hey, you want to know any term in this list? It's n, the term number you're on, plus the previous term. That's what that formula is saying. A sub n minus 1 is previous term. It's n minus 1. It's one term back. So it's saying any term is your term number plus your previous term. That's what that formula is really saying. So if I come in here and go, okay, so you're saying to find the second term, any term, you take the term number, the 2, and you add the previous term, negative 4.
Which is negative.
Comes out negative 2. There's the second term. Make sense?
That's easy. That's really
Yeah, once you speak their language, it's not that hard. You just got to get their language down, huh? Just got to hear what they're saying in that weird subscript language. Try the next one. A sub 3.
So then we 3 plus
negative 2.
negative 2,
So it's the term. So any term is the term number
1,
plus the previous term. What's the previous term?
2,
Negative 2. So it's 1. That good?
plus
And try 4 and 5.
Oh, shoot.
It's called recursive because it recurs. In other words, it goes back. It goes back and says, what was the last one? It's in other words, if I asked you all of a sudden, hey, what's the 100th term? You couldn't give it to me. You would need to know the 99th.
And had to keep going all the way to 9.
You can only do one step at a time, right? And this, right? Because every step is dependent on the previous step. You got to recur. You got to go back to the previous. So it's 4. It's the term number plus the previous, which is 1. 5. Good. And then again, it's the term number plus the previous 5, 10. There we go. Do you see the pattern in the numbers overall, by the way? Math is the science of patterns. Do you see the pattern? What's the pattern in -4, -2, 1, 5, 10?
It's adding the next number.
Yeah, so what's the first one added?
2,
Add 2, and then what do you got to add to get the next one?
3,
Add 3,
add 4.
add 4, add 5. See what it's doing? Nope, that's what it's doing. There's patterns. All right. All right, so maybe that's a little small. Let me write that out for you. So a sub 1 is 5. So the first term is 5. And then the formula that they give me is that. So try that one. See if you can. They want, so A1, that's 5. We got that one. So then they want A2, A3, A4, and A5. Can you find A2? Try A2. See if you can use that formula. So it's saying any term is the previous. Remember, an minus 1 is previous. That's the key to reading their language, speaking their language. Any term is the previous over the term number squared. That's what that formula is saying, huh? Any term is the previous over the term number squared. So A2, for example, is the previous 5, right, the previous, over the term number squared. That'd be 2 squared. So 5/4. Right, good. This one's going to get a little more messy. Need some more room here. So good for A2. It's always the previous over the term number squared. So try A3 now. That'll be more messy. So it's the previous 5/4 over the term number squared. 3 squared, 9. So it's 5/4 over 9, like that. Now we got to clean that up. How do we clean up 5/4 over 9?
You flip the 9.
Put 9 over 1, flip it up, 1/9, right?
536.
So that's 5/36. So a sub 3 is 5 over 36. I'll do one more. Let's do a sub 4 maybe. So is the previous 5 over the term number squared. 4 squared. So that's 16. So it's 5/36 over 16. Put that over 1. Flip it up. 1 over 16 times it. So that's 5 over some big number. Thank you. 576. And then, dot, dot, dot. A5 is the same thing. That good? So it's all about speaking their language. Any term is the previous over the term number squared. A minus 1 means previous. Recursive. It goes back. Okay, so they say A1 is capital A. They're just going to use letters now instead of numbers, variables. So the first one is capital A. I can fill that one in. And they're saying A sub n, any term, is A n minus 1 previous plus 7d. any term is previous plus 7d.
Is it plus 70 or to the 7
7.
times D?
7d, just simply the letter, the variable, 7d. So any term is the previous plus 7d. So let's come on down here.
A plus 7D equals
A2. So what's A2?
7D.
Well, it's the previous, yeah, which is A plus 7d.
Yeah, no, we keep going. Easy peasy. Yeah, it's pretty easy.
And then A3, what's A3?
Plus 14D.
Right, the previous. A plus 7d, isn't that the previous, the whole previous? Plus another 7d. You just always take the previous and add another 7d, which is going to basically be A plus 14d. Get the idea? You're just adding 7d on the back every time.
That would
good.
suck if your letter's broken on your keyboard.
So A sub 4, can we just jump to the answer?
Yeah.
Add 7d. 21d, right? It's like football, it's touchdowns. 14 points, 21 points. A sub 5, 28d. Just keep adding 7d. That's what this is saying, huh? Just take the previous and add 7d. Good? So that big thing is a big Greek S. Sigma is technically what it's called. And it's pretty simple. It just means you're going to take that formula k plus 3. So it means start at k equals 1, then go to 2. Yeah, down here, the number on the bottom is where you start. The number at the top is where you end. So you start at k equals 1, then go up by 1 every time, 2, 3, etc., dot, dot, dot. And the last one, where am I going to end? In. End at in. So that's a big Greek symbol, which means, and the S stands for sum. Add them up. So I'm going to figure out each of these and put plus signs between them. I'm going to add them all up. That's what that means. Sum up the following items. It's saying add up the following items, a big Greek S. So you take the formula k plus 3, and you plug in 1. 1 plus 3, 4. You take the formula k plus 3 and you plug in 2. It's going to be 5. Take the formula k plus 3 and you plug in 3. 6. Take the formula k plus 3 and plug in n. N plus 3.
It says first, second, and last.
Yeah. So all it wants is the first one, which would be not 3 but 4. It wants the second one. First one's 4, second one's 5. The last one is n plus 3. Make sense?
Can we find that or no?
Not in this one. The other ones, maybe. All right. So.
You're making your business look bad. That one.
All right. So on this one, same thing, but where do we start? Yeah, start at 0. So that's all. So it'd be 1 over 9 to the 0, which is 1 over 1, which is 1. 1 over 9 to the 1, which is 1/9. 1 over 9 to the 2, which is 1/81. Dot, dot, dot. Right? 1 over 9 to the n. Like that? Good? Let me see what I can do. You got that? Right, good. So just remember, whatever numbers in the bottom is where they start, they can start anywhere they want. They don't have to start at 1.